Hello GATE aspirants. Welcome to part 7 of GATE Thermal and Statistical Physics series. Question number 8. The total power emitted by a spherical black body of radius r at temperature T is P1. Let P2 be the total power emitted by another spherical black body of radius r by 2 kept at temperature 2T. The ratio P1 by P2 is. Now we know P is equal to Stephen's constant sigma into area into T raised to 4. So that is sigma then 4 pi r square into T raised to 4. So P is proportional to radius square and temperature raised to 4. So P1 by P2 is, this will be r square T raised to 4. The radius is half, so this will be r square by 4, and temperature is doubled, so this will be 16 into T raised to 4. So this is 1 by 4, which is equal to 0.25. So answer is 0.25, and answer in the answer key is 0.25 to 0.25. Next question. The entropy S of a system of n spins which may align either in the upward or in the downward direction is given by this expression. Here Kb is Boltzmann constant. The probability of alignment in the upward direction is P. The value of P at which the entropy is maximum is. So here we have S is equal to minus of Kbn in bracket P ln of P plus 1 minus P ln of 1 minus P. And it will be maximum when ds by dp, this is equal to 0 for maximum. So let us take derivative of S with respect to P. We have minus Kbn, then this will be P upon P plus ln of P plus 1 by P minus 1 by P into minus 1 plus ln of 1 minus P into we have minus 1, and this is equal to 0. So 0 is equal to minus of Kbn in bracket 1 plus ln of P, this will be minus 1, then we have minus of ln of 1 minus ln of P, ln of 1 minus P. This equal to minus 1 will cancel out. So Kbn cannot be 0, so that means this has to be equal to 0. That means ln of P will be equal to ln of 1 minus P. That means P is equal to 1 minus P. That is 2P is equal to 1 and P is equal to half. So value of P is equal to 0.5. So answer is 0.5, and answer in the answer key is 0.5 to 0.5. For a system at constant temperature and volume, which of the following statement is correct? So here temperature and volume is constant. So temperature and volume is constant. So dt is equal to 0 and dV is equal to 0. Then we have Helmholtz free energy. It is given by, now dF is equal to, its differential is given by minus P dV minus S dt. But dV is equal to 0 and dt is equal to 0. So that means this will be 0. That means this it attains local minimum here. That means Helmholtz free energy attains local minimum. So that means option A is correct. Gibbs free energy will be relevant when pressure and temperature are constant. So if pressure and temperature are constant, then in that case dg is equal to vdp minus sdt. So that will be equal to 0, 0. So then G will attain local maximum. Here temperature and volume is constant, so Helmholtz free energy will attain local minimum. Next. N atoms of an ideal gas are enclosed in a container of volume V. The volume of the container is changed to 4V while keeping the total energy constant. The change in entropy of the gas in units of nkb ln2 is. Now delta S is equal to integration over dq by t. But dq can be written as du plus pdv from first law of thermodynamics upon t. Now du is equal to n cv dt upon t plus we have p by t. Now p by t can be written as nr by v from ideal gas equation into dv. So here this is 1 upon t integration of 1 upon t dt. So that is n cv ln of tf by ti. Similarly, this will be nr ln of vf by pi. So this is delta S. But here energy is not changing. So energy is constant. That means temperature will be constant. So tf by ti will be 1 and ln of 1 is 0. So this will be 0. Now we have nr. Now n is number of moles which can be written as n by Na, and r is Na into Kb. Into we have ln. Vf is 4V upon initial volume is V. So this will be equal to n Kb ln of 4, which can be written as n Kb ln of 2 raised to 2. So this will be 2 into n Kb ln 2. So in the units of n Kbt ln 2, this will be 2. So answer is 2. 2 to 2. Next we have, consider a system having 3 energy levels with energies 0, 2e and 3e with respect to degeneracies of 2, 2 and 3. 4 bosons of spin 0 have to be accommodated in these levels such that the total energy of the system is 10e. The number of ways in which it can be done is. Now here we have energies 0, 2e and 3e, and corresponding degeneracies are 2, 2 and 3. Now we have to find out their numbers as well. Now total particles are 4. So n1 plus n2 plus n3 is equal to 4. Also their energy is 10e. So n1 into 0, its energy is 0, plus n2 into 2e plus n3 into 3e is equal to 10e. So that means 2n2 plus 3n3 is equal to 10. Now we have these two equations, equation 1 and equation 2, which we have to solve. Now let us consider some values. All of these numbers cannot be greater than 0, cannot be greater than 4. So let us find out its maximum value. Now if we consider n3 is equal to 4, if I consider n3 is equal to 4, then that means n1 is equal to n2 is equal to 0. Let us check if it satisfies equation 2 as well. So if n3 is 4, 4 3 it will be 12. So this is not possible. Then if n3 is equal to 3, then that means n1 or n2, any one of them, it will be 1. And here energy will then be 3 into 3, that will be 9. So that means n2 will be half. So that is also not possible. So let us see if n3 is equal to 2. So if we consider n3 is equal to 2, then that means from this second equation, n2 will be 2. And that means from first equation, n1 will be 0. It is satisfying this both equations. So this will be like this. We have energy 3e, 2e and 0. So here there are 2 particles, here there are 2 particles. Now we have to find total number of states. So this is 0, 2 and 2. Now total number of states is equal to multiplication over I, Ni plus Gi minus 1 factorial upon Ni factorial Gi minus 1 factorial. So this is equal to. Let us calculate these values for each case. So first we will have N1 G1 here, then N2 G2 and N3 G3 and multiplication of all those. So first case, Ni is 0 plus Gi is 2 minus 1. It's factorial upon 0 factorial, then 2 minus 1 factorial. For the second case, we have 2, 2. So 2 plus 2 minus 1 factorial upon 2 factorial, 2 minus 1 factorial. Then we have 3, 2. So this will be 3 plus 2 minus 1 factorial, 3 factorial, 2 minus 1 factorial. So this is 2 minus 1, 1 factorial, which is 1 upon 1. 2 plus 2, 4 minus 1, that is 3 factorial upon 2 factorial. So 3 upon 2 minus 1 is 1. So into 3. Then here we have 4 factorial upon 3 factorial. So 4 upon 1 factorial. This will be 5 minus 1, 4. 4 factorial upon 3 factorial. That is 4 upon this number. So this will be 2 into 3. So that is totally 3 2s are 6, 3s are 18. So total number are 18. So this will be 18 into, this answer was 18 to 18. So here answer 18 is correct. Here it is 3 minus 1 factorial. Here it is 2 factorial and here it is 3 minus 1 factorial. Next question. 46. A two-level system has energies 0 and E. The level with 0 energy is non-degenerate. We have 0 with degeneracy is 1. While the level with energy E is triply degenerate. So this is EI and this is GI. The mean energy of classical particle in this system is. So first of all, let us calculate partition function, which is summation over I, GI e raised to minus beta EI. For first when it is 1, e raised to minus beta, here it will be 0, plus 3 into e raised to minus beta and E. So that is partition function, 1 plus 3 e raised to minus beta E. And then mean energy is equal to summation over EI, GI e raised to minus beta EI upon Z. So this will be equal to 0 into 1 into e raised to minus beta into 0 plus energy is E, degeneracy is 3 into e raised to minus beta E upon Z. So this will be, first term will be 0 and we will have just this. So this will be 3e e raised to minus beta E upon this Z. So here option D is correct. So these were all the questions from GATE 2016 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.